Alright, hi guys. This video is going to be on the Module 11 practice quiz. For those of you that don't use this textbook, this is just solving systems of equations. So what we're going to do first is solve systems using graphing. So we have been given two equations and we're going to graph each and then find out where do they intersect. Now don't forget, they can either intersect at one place, nowhere, so if they're parallel, or they can basically be the same line, and so that would be infinite solutions. Okay, so let's graph these. Now the easiest way to graph, and I show my students this, I think, is to solve for y so that you have each line in slope-intercept form. So the first one, if I want to solve for y, I would add y to both sides of the equation. I'm going to write that a little bit small. So I have negative x on the right side of the equation, and on the left side I have a 4 plus y. Now I only want y, I don't want 4 plus y, so I'm going to subtract 4 from both sides of the equation, and I have y equals negative x minus 4. Now this is my first equation that I'm going to graph. So I'm going to go onto my graph and I'm going to plot negative 4, that's my y-intercept, and my slope is negative 1, that's right here, negative 1. So that's going to be down 1 to the right 1, or you can move up 1 to the left 1, okay? I'm going to go in with a straight edge so that I make sure this is really straight, and I've got my first line. Okay, then with a different color, just so you guys can see this easily, we're going to graph the next one. Again, the first thing I want to do is solve for y. So this one, to solve for y, I'm going to add y to both sides of the equation. So I'm going to write that work down here. I've got y minus 2 on the left side, 5x on the right. And then I need to add this 2 to both sides of the equation. So I've got y equals 5x plus 2. So that's my second equation. So again, I'm going to graph this. I've got a y-intercept of positive 2, slope of 5 over 1. Oh, but if I move up 5, it's going to go off my graph. So instead, I'm going to move down 5, 1, 2, 3, 4, 5, and then this is positive slope, so I'm going to move to the left one. Okay, so again, we're going to line up my 2 points, graph my line, and then we'll see actually that one point that they crossed over, that's our solution. It's where they intersect. So my solution is negative 1, down 3. And that's your answer. So remember, solutions to systems of linear equations is where the lines intersect. All right, let's try it with the next one. If I graph the first one, ooh, this one is already in slope-intercept form, so I don't have to do any algebra. So all I have to do is find the y-intercept, that's positive 2, and my slope is negative 1. So that's down 1 over 1, down 1 over 1, just like that. Okay, so I'm going to go in, connect those, and I have my first line. Then forget it, we're done with the first one. Now we're going to move on to this one. Well, I already have y equals something, but it's not written the way I'm used to. So I'm actually just going to switch this equation. So I'm going to write y on the left side of the equation, and then I'm going to write this on the left side. So that's okay, we can do that. Okay, same equation, I just swap-swapped. Okay, so this one, my y-intercept is 4. Remember, it's just the constant. So 4. And then the number in front of x is 1, because there's just an invisible 1 there. So your slope is positive 1. Up 1 over 1, or we can go down 1 over 1. Okay, so I'm going to connect these. I just did these in the same color. Hopefully we can see the difference between the two lines. And you'll see really easily that these intersect at the point negative 1, positive 3. So that's the solution to this system. Okay, so this is how we solve it with graphs. Now we're going to find the solution using substitution. So that means I want to solve for one variable and then substitute it into the other equation. So remember, when you're trying to find which one you want to solve for a variable, find the equation that has a 1 or nothing in front of one of the variables. So that's my first equation in this situation. So I'm going to solve this first equation for y. So I'm just going to subtract 3x from both sides of the equation. So this first equation now I'm going to write as y equals negative 3x minus 7. So I just rewrote that one. So I'm just going to cross it out. We don't need that anymore. Then I'm going to use this right here, what y equals, and substitute it in for y in the other equation. So I'm going to write 3x minus 7, but then instead of y, we're going to write all of this. Negative 3x minus 7. And then let's solve for x. We now have an equation with only one variable, so we can solve for x here. So I have 3x, and then I'm going to distribute. Plus 21x plus 49 equals 1. Still just solving for x. I can combine like terms. So if I combine like terms, I've got a 24x plus 49 equals 1. I need to subtract 49 from both sides of this equation. So now I have 24x equals, well, 1 minus 49 is going to be negative 48. And then I need to divide both sides by 24. Okay, so I get my x value is negative 2. So I'm halfway done with my solution. So my solution is negative 2 comma something. We'll put that in a box so we know that's going to be our solution. Okay, then we're going to take this negative 2 and we're going to substitute it into this equation. I want to know what my y equals. So I'm going to do that in a different color. Y equals, and then instead of x, I'm going to write negative 2. So I just rewrote this, but I plugged in x. Okay, so just simplify. Y equals, this is positive 6 minus 7. So y equals negative 1. So this is your solution, negative 2, negative 1. All right, let's try this one more time. So again, take a look at the two equations. Find the one that would be really easy to isolate one of the variables. Now if I look, I've got a 1 and a 4 in front of these, and then I've got a negative 6 and a 7. Now this means I'm definitely going to want to solve for x in the first equation. Okay, so I'm going to subtract 4y. So I'm going to rewrite this first equation as x equals negative 4y plus 22. So that's what I'm going to substitute in for x in the other equation. Okay, so we're going to cross that out. We're done with that one. We're going to take this equation and I'm going to rewrite it, but I'm going to rewrite this for x. So negative 6 times, and then instead of x, write this whole piece, negative 4y plus 22 plus 7y equals 23. All right, so don't forget, you got to distribute first. So I've got positive 24y minus 22 times 6, so you may need to do that in your calculator. So that's going to be minus 132, and then just write everything else. And then we're just going to simplify, solve for y. So I can combine like terms. I've got a 24 and a 7y. So that's going to give me a 31y minus 132. We're going to add 132 to both sides. So that's going to give me 31y equals 155. And then we're going to divide both sides by 31. That actually gives me a nice number. Y is going to be 5. So again, I always like to start off my answer once I already know one of the values. So I know my answer is going to be something, comma 5. Okay, so let's use this y value and we're going to substitute it in for y in that original equation. So just so I can keep my work kind of neat, I'm going to write this in a different color. So I'm going to rewrite this, negative 4, but instead of y, I'm going to write 5 plus 22. So x equals, when I multiply these, that gives me negative 20 plus 22. And so this is like 22 minus 20. So x equals 2. So that's my x value. Okay, we have found our solution for this one. Now don't forget, since we were finding the solution, that means that if I were to graph these, if I had done these the graphing method, then I would have found that these would have intersected at 2, 5. Okay. Next few are using elimination. So you need to look and see, can I just add them together to eliminate a variable, or do I need to multiply by something first? So this first situation, I have a positive 2 and a negative 2 in front of y. That means if I were to add these two equations together, our y would be eliminated. So that means I can just go right off into adding these together. Okay, so this is negative x plus negative 3, so that's a negative 4x. 2 plus negative 2, that's just 0, so those are eliminated. And then negative 7 plus 3 is negative 4. Divide both sides by negative 4, and we get x equals 1. Okay, so we've got half of our answer. Our x value is going to be 1. Then take this x value, plug it into one of the equations. Doesn't matter which one. So I'm going to substitute it into the first one. So instead of x, write 1. And then I'm going to solve for y. So I'm going to add this 1 to both sides. So I've got 2y equals negative 6. And then you need to divide by 2. So that means my y value is negative 3 here. Oop, I should finish those parentheses. Okay. The next one, though, we do not have the same number or coefficient in front of either of the variables. We have the same 9, but that doesn't help us. So that means I'm going to take a look at one of the equations and see, okay, what do I need to multiply the equation by to make it look like the other equation for the coefficient? So I've got a 9 here, so I could multiply it by 9 so that I have a 9 and a negative 9. Or I have an 8 and a 2. I could multiply this by 4 to get to 8. So it really doesn't matter which one you do. I like smaller numbers, so I'm going to multiply the the bottom equation by 4. So if I rewrite that, that's going to be negative 4x minus 8y equals negative 36. I'm going to kind of cut this off so we don't get mixed up. And then we didn't change the top equation, so don't change it, just write it as is. 9x plus 8y equals negative 9. And then since we did that, now if we add these together, the y's will be eliminated. So 9x minus 4x, that's going to be 5x. 8y minus 8y, that's just 0, so those are eliminated. And then negative 9 plus negative 36, that's some quick mental math. So that's going to be negative 45. Divide both sides by 5. And you get x equals negative 9. Okay, so starting off writing my answer, I know my x value is negative 9. Okay, and then in a different color, I'm going to substitute this x value into one of these equations. Let's just do the second one. That might be a little easier. So the second one is negative x minus 2y equals negative 9. Okay, distribute that negative. So this is really a positive 9 minus 2y. And then I need to subtract 9 from both sides. That's negative 2y equals negative 18. And then last step, divide by negative 2. So I get y equals positive 9. So that's my y value. Okay, so we have our solution here. It's negative 9, 9. You'll notice all of our solutions for systems of equations are either ordered pairs, no solution, we didn't get one of those yet, or infinite solutions. Those are the 3 ways you can write your answers. Okay, last problem is our word problem. So let's see what we're talking about here. We've got 2 people, Jacob and Stefan, or Stephen, and then they have hostas, I'm not sure if that's pronounced correctly, and grass. So we're talking about 2 different plants. Okay, so we're going to write 2 equations. Remember, we're solving a system, so we need equations. The first equation is going to be for Jacob. The second one is going to be for Stefan or Stephen. Okay, so for Jacob, Jacob spent $89, so that's the total, for 7 of our x, we'll make this x, and 13 of the grass, which will make y. For our other person, we have 116 as the total for 10 of these plus 13 of these. Okay, so we can either use graphing, substitution, or elimination. Now it's up to you, but I, as a mathematician, am looking at this and saying, ooh, I have a 13 in front of my y's. So that tells me I want to use elimination. But they're both positive. Those will not be eliminated if I add them. So that means I'm going to take this whole second equation and subtract it. So I'm going to do 89 minus 116, and that's going to give me negative 27. 7 minus 10 gives me negative 3x. And then 13 minus 13, that gives me 0. So those are eliminated. Okay, so we just have this simple equation to solve. Divide both sides by negative 3. And we get x equals positive 9. So I already know part of my solution, my x value is 9. Okay, then the easy part. We already know what x is. So take this x value and substitute it into either equation, doesn't matter which one. I'm going to pick the first one. So we're going to do 89 equals 7 times x plus 13y. All right, well, what's 7 times 9? So we have 89 equals 63 plus 13y. Subtract 63 from both sides. 89 minus 63 is 26. And then divide both sides by 13. So we get y equals 2 here. Okay, so that's our other part of our solution. Okay, so this means that the cost of one hostess, if that's pronounced correctly, is $9, and the cost of the grass is $2. So there's your solution. All right, thanks for watching, guys. Good luck on your Module 11 quiz to my students.